In this episode, we will see about the sanitary wastewater treatment. The source and impurities in sanitary wastewater. We can see sanitary wastewater treatment plant receives the waste from all the toilets, bathrooms, kitchen wastewater, which consists of vegetable washes and the wash water from the wash basin and other areas. These all collected from the admin building, office building, all the exchanges from any industry. The dissolved oxygen is a amount of oxygen which is dissolved in the sewage water. Normally it will be very less. If it is less than 5 ppm, that will give odor, and that is because of the excessive organic matter present in water. The dissolved oxygen value will be less. Another important impurities is total suspended solids or solid materials, which include organic and inorganic matters which are suspended in the water. This will include silt, plankton, and industrial waste, which will increase the biochemical oxygen demand. This total suspended solids will give the odor and will increase the biological oxygen demand, biochemical oxygen demand. The important definition for BOG, the biochemical oxygen demand is the amount of oxygen consumed by bacteria and other microorganisms present in the impure sewage water while they decompose organic matter under aerobic. That is when air is supplied or in the presence of oxygen in aerobic condition at a specific temperature around 20 to 25 degrees centigrade. The requirement of oxygen for decomposition is called biochemical oxygen demand. Another important terminology is chemical oxygen demand, COD. This is the amount of chemically accessible material present in the sewage water or wastewater, mainly organic substance, which is normally more than biological oxygen demand. The chemical oxygen demand is more than biological oxygen demand, as organic matter is oxidized chemically, which is more than biologically required amount. It includes biodegradable and non-biodegradable organic impurities. So it is almost 3 to 4 times more than biochemical oxygen demand. So chemical oxygen demand is more the oxygen demand which completely oxidize all the organic material present in the sewage waste or wastewater waste. Then one more important terminology used is this is present in food waste called azote TKN or NTK. This is the sum of nitrogen amount in the organic substances or nitrogen in ammonia and in ammonium in a water body. That it is in case the sewage discharge which is having the azote NTK as in the water body should be around 15 to 20 gram per person per day. That is normally this is a specific factor. It is one of the factor which converts the nitrogen content to protein content in selected foods like egg, meat, or soya, or any other food. For specific foods, a specific factor which is required to convert the nitrogen content to protein content in a human waste, human food. That is called azote NTK or azote TKN. This value will be around 15. Normally, it should be around 15-20 gram per person per day in the sewage effluent which is coming to the sewage treatment plant. Normally, sanitary wastewater is treated by biological treatment by means of aerobic process or anaerobic process. Aerobic process is best one. The total suspended solids and BOD in sewage inlet water may be between 100 to 4000 milligram per liter. But usually TSS may be around 300 to 400 ppm the sewage inlet from the plant or municipality, and BOD biochemical oxygen demand may be between less than 330 to 450. That is biochemical oxygen demand slightly more than the TSS. That is, if it is 300 TSS means the BOD will be around 330. So it's 400 means around 450. Chemical oxygen demand is more than BOD, 4 to 5 times. So in the incoming sewage water, it will be from between 900 to 1500 milligram per liter. This is the inlet water quality or impurities in the sewage inlet effluent. The sanitary sewage from all the locations are collected in pits, and submersible pumps are used to pump it to the tank called equalization tank. This is having 4 chambers where biological treatment is done to convert activated sludge, and sludge is separated and purified water is disinfected and treat and used as a reused water. The sewage water impurities consists of total suspended solids. It will be around 300 milligram is oxygen required per liter. Biological oxygen demand is 330 to 350 milligram oxygen required per liter, and chemical oxygen demand is around 750 to 900 milligram per liter oxygen is required. Azotic ion, as we seen, is around 15 to 20 gram per person per day. So this is the impurities present in the sewage inlet water. It is coming to the equalization tank. Equalization tank is provided to aerate waste to avoid septicization. This by means of air blower through diffusers. Air blower supply air which is passed through the diffusers, fine bubbler type. It is at the bottom of the tank with a downcomer and isolation. We can adjust the flow rate so that the DO is maintained in the equalization tank itself to reduce the odor. And the pH of sanitary sewage also is maintained between 6 to 9. And then it is used as a reused water uh, for gardening. It is maintained by sodium hydroxide dosing in the equalization tank. Now we can see the biological treatment. In the aeration tank, the activated sludge which is grown by means of the air through blower. The air through blower is admitted to the bottom through same diffuser, fine bubbler type. It is removing the organic matter present in the wastewater or sanitary waste. This is continuously fed through the dedicated blowers to maintain the DO between less than 2 to 5. Should not be less than 2. It will give odor, and a sludge will not be formed, activated sludge. If it is more than 5 also, it will decompose the sludge. So we have to maintain between 2 to 5 or 2 to 4 ppm. The aerated mix from the tank is fed to the clarifier. So the aeration is maintained in the aeration tank by means of the dedicated blower, and DO is maintained between 2 to 5 ppm. DO meter is situated in the tank to monitor the value of the DO. It will give alarm when it goes to less than 2 or more than 5. Based on that, we have to adjust it. Either we can adjust it automatically, or we have to do it in manual. And when the aeration aerated mixed water is fed to the next compartment called a clarifier. It is a static type and in square in shape clarifier tank, which is provided with a quietening downcomer. Quietening downcomer is that is nothing but very static one with no disturbance, so that the activated sludge will grow and settle at the bottom. It is also having a scum barrier, so the baffle plate, which will not allow the sludge material to carry over to the next compartment. And it is having a wire also, wire arrangement. The activated sludge normally settles at the bottom, and it is recycled continuously to the aeration tank by means of pumps to maintain the activated sludge. If the DO is maintained exactly between 2 to 5, and organic matter and bacteria are converted or decomposed to form activated sludge, and the activated sludge is recycled and the sludge is settled at the clarifier due to the arrangement in the clarifier tank, and clear water is overflown to the chlorination tank through wire by means of gravity. If the sludge is excess or more or dead sludge is there, that will float. Then it is to be removed and discharged to sludge removal system for further incineration. Belt pressed unit where it is sludge is belt pressed and sent to incineration, or it can be disposed as a manure. So the dead sludge, it is quantity also to be maintained in the clarifier. Time to time we have to remove it from the bottom, and the activated sludge also is to be recirculated to the aeration tank bank. So it is maintained, and clear water is fed to the chlorination tank. The clarified water is fed to the chlorination tank by means of gravity. It is flowing through the wire at the top of the clarifier tank. In the chlorination tank, disinfection is done. It is carried out by the hypochlorite solution to get a free residual chlorine of 1.5 to 2 ppm to kill the coliform present in the RNA bacteria or microorganism present in the sewage water. The chlorinated water is then sent to the dual media filter through pumps to remove the TSS. The dual media filter is normally packed with anthracite gold and quartz sand. Quartz sand is white in color, and it consists of more silicon dioxide. It will be more than 95%, whereas normal sand, which is brown in color, where the SaO2 silicon dioxide content will be less than 80%. So this is white in color and having more silicon dioxide. This will remove suspended solids, colloidal impurities from water effectively. This quartz sand is used to remove the TSS effectively. The filter is to be backwashed if the delta P across the bed is more than 1 bar, or once in a shift it is to be backwashed. The filter water with less than 20 to 30 milligram per liter, which is reduced from 300 milligram per liter oxygen, milligram oxygen per liter, is reduced to 20 to 30 at the outlet of dual media filter, and is sent to reused water tank. And the reused water is used for gardening or for further treatment for zero liquid discharge, where we have to use ultrafiltration, reverse osmosis, or nanofiltration with a with a membrane filter, so that we will get a zero liquid discharge, which is the latest technology used in wastewater and sanitary wastewater to discharge the water with a high purity. Now we can see the sewage water inlet and outlet quality. Normally the inlet water will contain BOD5, that is biological oxygen demand. If you collect the sample, and it will take 5 days to grow the BOD to check the value, so it is called BOD5. It is around 9.8 kg oxygen required per day, or 330 milligram oxygen per liter, and chemical oxygen demand is 42 kg oxygen required per day, is more than BOD almost 4 times, or 700 milligram of oxygen per liter, and TSS around 18 per day, or 300 milligram oxygen required per liter in the inlet water. And another terminology, azote NTK, is 15 gram per person per day. And we have to maintain dissolved oxygen in equalization tank at the inlet of the sewage treatment plant around 2 to 5 ppm. Should be maintained in equalization as well as aeration tank also. And the outlet water contains BOD from 330 milligram oxygen per liter to 15 milligram oxygen per liter, which is very normal. If it is more, that is load is more, means then it will go to 25. is allowable limit. 25 milligram oxygen required per liter. That is at peak load. Same like COD is reduced from 700 milligram to 100 milligram oxygen required per liter, which is normal. If it is at peak, then it will goes to 150 milligram oxygen required per liter peak value. Same TSS is reduced to 20 milligram per liter, which is normal, and it may vary to 30 milligram per liter peak. It is reduced by means of dual media filter. These two BOD and COD is due to the aeration, and the TKN also will reduce from 15 gram to 0.1 milligram normal, or 0.5 milligram is more at peak. This is a value which also get reduced by aeration and active sludge formation. Then the value in the outlet water, the chloride will be less because it is coming as human waste and wash water only. So chloride was normal raw water only. So it should be less than 15 milligram per liter, and it is around 30 milligram per liter peak. Phosphate also 50 milligram per liter. Maximum is 25 milligram per liter. Oil and grease normally will not be present. It also will get filtered in the dual media filter. So its value will be around 8 milligram per liter. Maximum will be 15 milligram per liter. And the pH of the reused water or clarified or clear water after the chlorination is around 6 to 9. This pH is maintained from the beginning itself. The equalization tank itself, NaOH sodium hydroxide is used to maintain the pH value. And in the chlorination tank, we are admitting hypochlorite solution to maintain 1.5 to 2 ppm of chlorine. This will kill the coliform or bacteria present in the water. In the outlet water, normally should be less than 10. The maximum value should be 23 mpn, most probable number in the sewage effluent after the treatment in the aeration tank clarifier, followed by the disinfection in the chlorination tank. Hope you might have understand the sanitary wastewater treatment by means of biological treatment. Aerobic process is used. Aeration is done in equalization tank and in aeration tank to maintain the DO between 2 to 5 to grow activated sludge or active sludge, and to reduce BOD and COD. BOD is reduced from around 330 milligram oxygen required per liter to less than 30, and COD to from 700 milligram oxygen per liter to 100 milligram oxygen per liter, and the TSH is also reduced in the dual media filter from 300 to less than 20 milligram per liter, and azote NTK or TKN value from 15 gram to 0.1 milligram per person per day reduced. Then it is disinfected with the hypochlorite solution in the chlorination tank. Prepares the free residual chlorine is maintained from 1.5 to 2 ppm to kill further microorganism or coliform present in the water, and the value will be around less than 10 mpn. Value design value is less than 23 mpn in the outlet water. So the chlorinated water from the chlorination tank is pumped to reused water tank, where the reused water is used for gardening, or it sent to further treatment as zero liquid discharge, which is used with ultrafiltration, RO or nanofiltration or membrane filter to treat the water to zero liquid, pure water. So pure water discharge in the next tertiary treatment. And in the coming episode, I will explain about the process wastewater treatment. Do not forget to subscribe. Please do subscribe, share it with your colleagues and friends. Put your like and comment in the comment box. Thank you very much. See you in the next episode.